Now we'll get into some of the testing here. The contractor, this is right out of the spec pretty much, that the contractor shall perform random QC sampling and testing of aggregate and asphalt mix as specified in the testing manual. And so what they do for every test they take, and they're going to do most of the testing out there, they're going to take it, they're going to take splits, they're going to split it in our presence, and they're going to take that split and they're going to go back and run it. The other half they're going to give to us. And all we do with this is we put it aside and make sure it's secure for a certain amount of time here. And if all the tests work out, then we can get rid of it. We don't test this one. This is just a split that gets set aside. And so speaking about getting samples, we want to make sure that we know where the aggregate sampling devices are at the plant and what type of sampling device. And we want to make sure that we approve this before it starts. The engineer has to approve these sampling devices. The frequencies for these tests, the contractor is to run, mix and aggregate samples about every 1,500 ton. And they have to also take samples for physical properties. And one thing that has changed now recently in the last few years is that the contractor will generate their own random numbers. We used to do that, but we don't do that anymore. They generate their own random numbers and they decide when they're going to go take a test. We have to know when they're going to take it. They have to tell us, or they have to give us a copy of that. As far as we're concerned, we're in the business for, as we talked about earlier, is that we're in the business of verifying this, making sure that, assuring us that the quality is being done right. So we have to take some tests too, and it's a lesser amount than the contractor, but we have to do it to verify that everything is working good. And so we have to get a separate test. A QA and a QC lab have to get separate tests. It cannot be a split. Now, we talked about the split earlier, but that was just for setting aside and not using it, just setting it aside in case there's some dispute. The test that we go out to get, we generate our own random numbers, the QA people, and we have a kind of an increased frequency for the first few tests, and then we can go down to once a day, but they have to be, I have to stress that it's separate. It's not a split. Sometimes what happens is that the QA and the QC kind of go out together and get their tests right side by side. That's really kind of a split. So the asphalt inspector should get their own random numbers, and they should go out whenever it says that they can go out to get them. It might be an hour, 2 hours after, or an hour or so, whatever, between when the contractor took it and when they did. So that's what keeps it all random, and that's what keeps it. That's a very important thing to know, is that everything has to be separate. Contractor, while they're taking these tests, they have to keep, they have to write everything, they have to document everything, they have to maintain control charts. And that's something that, and they have to be available to us as inspectors to look at. And so one of the things inspectors should do is verify that all the tests are being done, of course, and verify that control charts are accessible. They have to be accessible to anyone that walks into the QC lab, be able to look this up. It's easier when you get a bunch of tests going. It's easier to see what's going on with what they call a chart like this. And there's several of these charts. There's one here for air voids, but there's 7 or 8 more types. There's all the sieves have them, and then all of the physical property things and all the some of the mixed things. So it's better if you have a chart, because then you can see some trends going on. Now, that's the whole idea behind it. If you see some trends that aren't working very well, communication is number one. You want to make sure that you're talking to everybody, engineer, district materials lab, and of course the contractor. Why are these things trending out or trending towards the limits? So between the two labs, if the asphalt inspector's QA results are within tolerance, the contractor's results are accepted. And that's how a QC/QA operation works, is the contractor's numbers can be used as acceptance as long as the verifications are within tolerance. And so what happens if something doesn't work out? What's the protocol for for that, and that's in this field sampling and testing manual, the procedures for that. So I recommend, read over all these things, especially section 430 of the testing manual, because you're going to use every bit of it. And the same thing with the specifications. And so there are two different things that can happen out there. The QA and the QC can go out of tolerance, or the QC testing itself is not in the limits. And so there's a kind of a couple of different things, but these sort of lead to the same thing. And so if the tests are out of tolerance, if your QA tests and QC tests are out of tolerance as per the tables that are in the testing manual, then what normally happens here is contractor has to resample, but when they resample, this is where the materials district lab comes into play. They get a three-way split. Now we're talking about a split of aggregate, not a separate sample. We're talking about a three-way split between all the parties, and then that gets run, and then we determine what the discrepancy is, and then we move forward from there. So we're trying to do is troubleshoot this, and it's best to try to do all this as fast and as efficient as we can, because we don't want to let the problems get away from us. These plants put out a lot of tons, and so we want to make sure we get stuff straightened out fast, and get things back rolling normally. And so now we're kind of getting into more of the contractor part of it. If their tests maybe start to go out or something, so they have to adhere to these single tests and moving averages. So a single test is basically what it says. It's just a single test, and it has a wider limit than as you can see, than a moving average limit. A moving average limit target value is a little bit different. It's determined using the last 4 recent single test results. And it has a narrower limit. And this is the one that we really want to watch out there, is the moving average one. So here's just a typical, as we had earlier, of the air voids kind of blew up here a little bit. The red marks here are actually the single test limits, and they are wider, as you can see. Whereas the moving average, once the job gets going and you get a lot of tests, this is the one you want to watch. And that has a narrower limit. By the way, this one here is the moving tests, when they start to trend out, they're much harder or more difficult to move back the other way. So you don't really want to wait for those to get out, because you might have 2 or 3 tests after that trying to get out of, into a better range. So you want to kind of be more proactive with these moving average ones. So if a single test exceeds the limits, the contractor shall immediately take corrective action. Once you got your test result, they got their test results of this out, then they're going to want to do some type of corrective action. And then they want to, sample and take another test to see how that turned out. And if that passes, that's great. And then we can get back going. Now, that particular test they used to do the correction, that cannot be used. That has to be set aside now, because it can't be used in the moving averages. It's going to be, that's basically just for correction. And so as an inspector, then we need to be notifying the engineer that this stuff is out, the district materials lab, and then make sure we document what corrective action the contractor took, and keep monitoring things and moving forward. And hopefully things will work out there. If moving averages go out, it's pretty much the same thing. However, you don't really want to wait for them to go out. In other words, this one here says trends toward. So you want to kind of be more proactive, as I said earlier, in trying to fix those. One of the things during the project that the contractor is required to do is take readings of the totalizers that we talked about earlier in calibrating as the job is going through. So every time they take an aggregate test, the QC test, they're required to go in and get these readings off in our presence. The readings off the totalizer. These are all and over to this computer here, these are all in tons. This is tons per whatever time it was between the last reading and this one. And this all has to be entered onto a form called the asphalt content virgin aggregate determination. So really what this is all about is, at the end of the day, we're going to want to know how much binder we used in the mix. That's going to come from our tank sticks at the end beginning at the end of the day. We're going to figure out how much asphalt binder was used, but we also are really concerned about variability during the day. If we want 6%, for instance, in the mix, we don't want it to be varying at 5.5 and 6.5 all day long. We want it to be pretty, we want to be hitting, 6 or whatever it is, or 5 or whatever the target is, pretty close to that. And so that's what this form does. There's the form here that we're talking about. And this one, every time you do a test, and this is the asphalt content and virgin aggregate determination. So every time the QC takes a test, we have to get readings off this. And so these 3 readings, one of them, the top one here is the aggregate, and then the middle one is the wrap aggregate minus the binder that's in it. And then the bottom one here is actually the tons of asphalt that's been used. And so all this gets entered on this form, and then you could just a simple formula to figure out what is the actual, how much binder are we actually getting in it. And you can see this is actually running pretty close here for this particular project. And so all these numbers are put in here. And so if this varies too much, there's actually a penalty that has to be given. So contractors motivated to keep this very uniform. And that's why they calibrate the plant, is to make sure all this is doing well.